all of it. Okay, so we do a rectangle. And well, so we're looking at the definition first. The definition for that is a rectangle. First of all, has to be a parallelogram. Oh, sorry, a quadrilateral, like mean four sides. You can see that. And what makes this rectangle special is because all the angles are 90 degrees, all the right angles. You can see that. And so therefore, every rectangle is parallelogram. Well, we need to ask for why. Well, remember when we define the parallelogram is that the two corresponding sides are parallel. So we just had to prove that. Well, we know this side and this side are add together 90 degrees. And if you extend this side and extend that side and extend this side, what we have here is two lines and the transversal. And this is a consecutive angle. If they are supplementary, then those two lines are parallel. Well, which is they are supplementary, 90 plus 90, 180. So they're parallel. Similarly, we can prove that if you connect this side, then because this angle and this angle are 180, so this side and that side are parallel. So therefore, this and that parallel, and this side and this side parallel. So that is meet the definition of a parallelogram. So therefore, it is parallelogram. Okay, are we good on this one? Thank you, Mia. Thank you, Grayson. Okay, now we look at a rhombus. A rhombus that, again, the definition, we go that first. The definition is a quadrilateral, but with four congruent sides. So you can see that this and this, they are congruent. And therefore, the rhombus is a parallelogram. Well, again, when we learning about parallelogram, we said that parallelogram, the corresponding sides are congruent. So we know this side is congruent this side, and this side is congruent this side. So therefore, that is a parallelogram. Okay, are we good on this one? Yeah. All right, let's look at wrong square. Square is special, so actually it's pretty easy to prove that a square is a equilateral with four right angles. And so therefore, square is a special rectangle and also had four congruent sides. So it's also a special type of rhombus. And we know that a rectangle is parallel, so therefore square is also a parallelogram. So, okay, are we good on this? All right, now we're going to looking at the trapezoid. The trapezoid is quadrilateral. That's we know four sides, but there is what make that special is that it has exactly one pair of parallel side. Well, we know parallelogram has to have two sides, two pairs to make that parallelogram. So trapezoid only have one side, and the parallel side are called the bases. The other side are called legs. So you can see on the one on the left, we know this side and this side are parallel. So they are called bases. So the other one is leg and leg. Now, if we look at this one, we know this side and this side are not parallel. So those are legs. But this side and this side parallel. So we got base one here, base two here. So that's the definition for a traploid. And traploid has a special type. It's called isosceles traploid. And what made that special is the two legs are congruent. So this side, we know this side and this side parallel to make that traploid. But this leg and this leg are congruent. So that's called um, isosceles traploid. So we learned in the past about isosceles triangle is this and this are congruent. So it's similar to isosceles triangle, except that this time we have a parallelogram. You can also think about this isosceles parallelogram actually is part of an isosceles triangle. You can see that if you connect them. Okay, are we good on this one? Thank you, Mia. Thank you, Grayson. Now we're going to talk about properties of those four special quadrilaterals. So when we're dealing with properties, that's where when we're talking about theorems. Theorems always dealing with properties. So for anything, we have a definition. Definition tell us what that thing is. The theorem tell us what the properties of something. Okay, so on this one, uh, we're looking at properties. First of all, the diagonals of rectangle are congruent. And this actually we can easily prove by triangle congruency. So we got this is a rectangle, 90 degree, 90 degree, 90 degree, 90 degree. So we call this A, B, C, D. And if we draw the rectangle, of course, we got BC, and we can also draw that one as AD. So we can break that down into two right triangles. One is ACD, and the other one, which gave us another diagram. So you can see the diagonals are the hypotenuse of right triangles. And this is a B. This is a BDC. So this triangle and that triangle. And we know that this side and this side congruent, this side and this side congruent. So that's what we call leg-leg theorem. So therefore, those two triangles are congruent, and therefore, this side and that side are congruent. This is something we call CPCTC. So that's how we can prove that one. Okay, are we good on this one? Thank you, Mia. Thank you, Grayson. Okay, now we're going to looking at theorem. Next theorem, 2-7, 2. It said each diagonal of rhombus bisect two angles of rhombus. Well, we got, first of all, we know rhombus, all four sides are congruent. So if we do something like that, this. So we got A, B, C, D. So if you connect them, this one, we say this one, say each diagonal of the rhombus bisect two angles of the rhombus. So this one will bisect angle, this angle, and that angle. And this is actually pretty easy to prove. This basically we got two triangles. One is ABD. Another triangle is CBD. And we know this side is congruent this side is congruent this side, and this side actually that's the common side. So these two triangles are congruent by side. So therefore, this angle is congruent this angle, and this angle is congruent to that angle. So therefore, this bisect the two angles. Now, we can use the same way to see to prove this side. Yeah, so prove this side, basically we make two triangles. One is on the top and one is bottom. Again, this side congruent this side congruent this side, and this is the common side. So therefore, SSS. And because of that, we know this angle is congruent to this angle, and this angle is congruent to this angle. So that's how we prove theorem 2-7-2. Okay, are we good on this one? All right, wonderful. Okay, now we're going to looking at now. This actually is very important theorem. Is that when we have a rhombus, if we connect them, then this is 90 degrees. Okay, of course, this will be 90 and it'll be 90, it'll be 90. So that means the diagonals of rhombus are perpendicular. Well, let's see, we got A, B, C, D. Well, remember what we did here. We know this is the top one is an isosceles triangle, like ADB. And so therefore, this angle is congruent to this angle. And we also, based on previous theorem, this diagonal will bisect the angle A. So this is congruent to that. And we know this side is congruent to that. We remember triangle congruency. We got angle, side angle. So therefore, those two triangles are congruent. Now, if that's the case, we know this angle is congruent to this angle, and it has to be 90 degrees because this line here, the angle on one line here, this is 180. So this basically bisect that. So we got 90. So that's how we can prove that the two diagonals are perpendicular to each other. Good. All right. Thank you, Mia. Thank you, Grayson. Okay. Now we are going to looking at the next one. Give us examples. So now we have a rhombus ABCD, and what can we conclude? Well, first of all, ABCD is parallelogram. That's what we learned when we define the rhombus. So it has all the properties of a parallelogram. And also what's new here is AC is parallel to BD. And we know AC, this line is bisect DAB, basically angle A, bisect that. And also bisect this angle. And BD actually is bisect this angle. And that's what we learned. And actually we can have we can go further on this one. Is that we can even prove this side is congruent to this side, and this side is congruent to that side. So the diagonal not only perpendicular, and also they bisect each other. Well, this is something we learned about parallelogram. Parallelogram has that property. So therefore, rhombus is a special parallelogram, so it also had that property. Okay, are we good on this one? Thank you, Mia. Thank you, Grayson. Okay, now we're going to do something interesting. Is we have a theorem here. The theorem says the middle point of the hypotenuse of right triangle is equidistant from the three vertices. So basically we got the right triangle. We see here we got a right triangle, and we pick the middle point here. That means this side is congruent to this side. And if we connect here, we can see that uh, this point we say is equal distance from the three vertices. From here, from m to x is equal to m to y, so mx equal to my, and also equal to mz. So that's why we call equal distance. Okay, let's see how we prove that one. And to prove that one, actually, we're going to use what we learned here about a rectangle. So basically, what we're going to do is that we're going to draw a line parallel to YZ and draw a line KY parallel to XZ. So now we got a rectangle. And 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 based on the what we learned about rectangle, if we go back here about rectangle, rectangle said the diagonal of a rectangle are congruent. Okay, so we know we know therefore we know this line and congruent to that line. Okay, and knowing that, and we also know that back then, these two are bisecting each other. We say KZ and this line, KZ and XY, bisect each other. Well, the reason for that is because rectangle is a parallelogram, and we know parallelogram, the diagonals are bisecting each other. So therefore, this side is congruent to this side, and this side is congruent to this side. But also we know that KZ equal to XY, so therefore XM is going to be equal to MZ. So MX, or should we call that? MX is equal to MZ, and we know MX equal to MY. So therefore, that's how we prove that. This point is equal distance to the three vertices. And this is only true that if the triangle is a right triangle. If it's not, then it won't be true. Okay, we good? Thank you, Mia. Thank you, Grayson. Okay, now we're going to looking at some more theorems. And remember, theorems are about properties. Okay, anything when we study, we need to have a definition so we know what we are talking about. And after that, we are going to figure out what kind of properties of something. So that's how we study anything. Okay, when we study something new, first of all, we want to define it, and second of all, we want to find what is special about it. And that's basically the properties of that something. Okay, we look at here yeah. So this is not in, this is if. If an angle of parallelogram is right triangle, then the parallelogram is rectangle. Well, we know that for a parallelogram, this angle and this angle are congruent. Now, if this angle is right angle, and this one has to be right. And because this line and this line parallel, so this angle at this angle has to be 180. Since this is 90, this has to be 90. So therefore, same thing, this one has to be 90. So therefore, as long as you have one angle is right angle for parallelogram, and that parallelogram has to be rectangle. Yep. Okay. Are we good on this one? All right. Now we're looking at theorem 7-2-7-6. If two consecutive sides of parallelogram are congruent, then the parallelogram is a rhombus. Okay, so we got the parallelogram here and here. We know this is parallel, this is parallel. Well, if this side is congruent to this side, that's why it's called consecutive side. And based on the property of the parallelogram, the opposite uh, sides are congruent. So this will congruent to that. And this also congruent to that. So therefore, all four sides are congruent. And that's the definition of a rhombus. So therefore, that's how we prove it. And when we prove something is true, we always uh, uh, go to its definition. We are going to prove that something meet the definition. So therefore, we can prove that um, something is something. In this case, this parallelogram is a rhombus. Okay, are we good on this one? Okay, so now we're going to do some work here. I'm going to show you this example too. In the diagram below, the red figures are formed by joining the middle point of the sides of quadrilateral. First of all, what seems to be the common property of the red figures? Well, you just type that to me, okay? Yeah, on the chat. Tell me what you think. Yeah, if you don't know how to do it, you can say IDK, but look at the shape and see what do you think they are. Well, we got to be more, it is quadrilateral, but we have to be more specific. They are special quadrilaterals. And yeah, Grayson, very good. It is parallelogram, all of them. We can see that the, some might be rhombus, we don't know. Some might be a rectangle, but we just don't know. But one thing we know for sure, they are all parallelogram. And this and this are parallel, and this are parallel. Similarly, this and this parallel, and this parallel, and this parallel, and this parallel. Now this one looks like a rectangle, but we don't know for sure, but they are parallelogram. So they're all parallelograms. But now the tricky part is, oh, how do we prove that? And since based on what we learned so far, uh, actually is in the previous lesson we learned. So what you're going to do, the tricky we're going to do is draw a line like this. So because these are the middle point, remember we learned before for triangle, if you connect the middle point and this line is going parallel to this. Now, so this we're looking for this triangle. We can also looking for the other triangle. I'm going to draw that in a different color. We can also looking at this triangle. And this is the middle point. So therefore, this line is going to parallel to this line. Well, this line is parallel to this line, and this line is also parallel to this line. So this is our reference common line. So therefore, this line is parallel to this line. Now, similarly, we can draw the line go this way. And now we can see this is the middle point, this is the middle point, and this is the triangle. So this line is parallel to this line. And we can also looking at this triangle. So because this is the middle point, this is the middle point, and this line is also parallel to this line. So therefore, these two are parallel. So that's how we prove that what we ends up is a parallelogram. Yeah. Are we good on this one? Thank you, Mia. Thank you, Grayson. And oh. Now, for the other one, it's pretty much the same idea. If we can connect from here to here, then we can show that this line is parallel to that line for this triangle. And again, we can also looking at this triangle. So this is also the middle point. So this line is parallel to that. Therefore, this line is parallel to this line. And for the other two, we can connect like this. So this is the middle point. This is the middle point. So this line is parallel to this line. And this line is also parallel to this line. So therefore, this line and this line parallel. Okay. And so the other two is similar to this one. We just need to draw a line to make it right. Make a triangle. So this is parallel to this, and this is parallel to that. So therefore, they're parallel. And then we just draw something like this. You can see this parallel to this parallel to that. So these are parallel. Similar for this one. If we draw like this, we can prove this parallel to that, and this parallel to that. So those are parallel. Then we draw the line go this way, and we prove this is parallel to this line, and this is also parallel to this line. So therefore, those are parallel. So it's kind of interesting. This tells us a way to draw parallel lines very easily. We just draw any quadrilateral. Doesn't matter what kind of quadrilateral. It could be something like this. All we need to do is that find the middle point here, 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 and here. If we connect them, we got a perfect parallelogram. So this is kind of neat trick to draw parallelograms. Okay, are we good? Thank you, Mia. Thank you, Grayson. Okay, well, getting close. Okay, so now we're going to do the trapezoid. So trapezoid, look at this theorem. Base angles of isosceles trapezoid are congruent. Now, there's two ways to prove it. One way is that we are going to draw a line parallel to this line. So what we got here, we know traploid, we know these two bases are parallel. And now we see this side are parallel. So we got parallelogram. And because of that, we know this side is congruent to this side. And well, we all know this side is congruent to that side. Well, what we got here is a isosceles triangle. So we know angle 1 is congruent to angle 2. And because this line and this line are parallel, so this and this, that's the corresponding angle. So angle 2 is congruent to angle 3. Because angle 1 is congruent to angle 2, angle 3 is also congruent to angle 2, so therefore angle 1 is congruent to angle 3. So that's one way to prove that. Another way to prove that is draw a perpendicular line. And what we got here, we already know these two are parallel. And because this line are parallel, so, 90 degrees, so they are also parallel. And also the angle is not a triangle here, a right angle here. So what we got here is a rectangle, which means that if you look at the other side, this one, this is a right triangle, and this also a right triangle. So we can see that this side, which is hypotenuse, and those two legs are congruent. So that's the hypotenuse leg theorem. So we know these two triangles, PBX is congruent to triangle AQY. So, and because that, then we know this angle X, is congruent to angle Y. And this is something we call CPCTC. Okay, are we good on this one? All right. Yeah. So now we're going to learn a very important theorem from that. This theorem is about we call that median of a traploid. So what do we mean by that? That's the first thing we need to know. So the median of traploid is a segment, which is a line segment that joins the middle point of the legs. So joins the middle point of the legs. Actually use that. Note that the difference between median of traploid and median of triangle. So what is median of traploid? We just said that find the middle point on the leg and connect them. And that line it's called median. This line, MN, this line is a median. Connect the middle point. But the median for a triangle is basically a line from the vertex and to this line and make sure this is the middle point. So this line is a median. Well, for a triangle, actually, we got 3 medians because we could have median go here and the median go here. And those 3 median actually intersect at just one point. And that's because triangle had 3 vertices, we got 3 medians. But for traploid, we only have 2 legs here and here, so we only have 1 median. And you cannot do like this. This is not called median. It has to be on the leg. So for traploid, we only have 1 median. Okay, are we good on this one? All right, so now we're going to looking at this interesting theorem. So the theorem says the median of a traploid, there is 2 properties. First property is that the median is parallel to the bases. The second one is had the length equal to the average of the base height? Well, let's see. So basically, look at the first one. They said the median is parallel to the basis. So this median is parallel to here, and we know the two bases are parallel to each other. So if the median is parallel to this base, it's automatically parallel to the other base. So how do we do that? And when we prove something in geometry, we always draw some lines to help us. So now we're going to do that. We're going to draw the line here from S, draw the line down this way, and connect basically these two, S and connect and extend SN. And also on the PQ side, we extend that PQ, and we're going to meet at one point. And this is the point. We call that T. And now you can see we actually got a triangle here, this triangle. Then we can use the properties we learned earlier about triangle, because this and this, the middle point, and we learned that in triangle, if we connect the middle point, and this line is going to be parallel to the base. And therefore, and because PQ is parallel to SR, so we prove that MN is parallel to PQ, and also MN is parallel to SR. So that's the first thing we proved. Okay, we're all good on that one. Thank you, Mia. Thank you, Grayson. All right. So now we are going to use that triangle to prove it. Okay. Well, before that, we have to prove something. We got to prove there's two triangles here. This triangle and that triangle. And we want to prove that they are congruent. So, and the reason for that is then we can use, we learned about triangles. So that's why triangle is so fundamental. If we understand triangles, we can use triangles property to prove many other theorems. So these two triangles, one is SRN, and the other triangle, we got T, this point, Q, and N. Well, we know this angle and this are congruent because they're vertical angles. And now we know this angle and this angle are congruent. That's called alternate interior angles. So we got two angles and have a side because this N is a middle point. So we know RN is congruent to QN. And we already know that the angle NTQ is congruent to angle RSN. So this angle and this angle. That's the alternate interior angles. And we also know TNQ is congruent, is Q, to angle S and R because they are the vertical angles. Vertical angle are always congruent. So now we have angle, angle, side. So we can use that theorem to prove this angle is congruent to this angle. And the reason for that is we want to prove that QT is equal to SR. And that's what we know. It has to be. This is CP, So once we know that, that becomes easy because look at this triangle. And we learned early on, if we connect the middle point and this side is half the length of this side. So therefore, MN is equal to half PT. Or what's PT? PT is PQ plus QT. And we also know the QT is SR. Like here, we just proved that. So it's half PQ plus SR. And that's what we are trying to prove, is finding the median of the rectangle here, and that is the half of this and this. Or you can think about the median here is the average, the length, MN is the average of SR and PT. Okay, are we good on this one? Okay, very good. So we got one thing to example. That's the last one. Okay, the set trapezoid has the median shown. Find the value of x. Okay, we got trapezoid. We can see that this side is congruent to that. Those are the bases, and the other will be leg. And you can see that this is a median. You can see this side is 7, this side is 7, and this side 6, this side 6. And so this is really the median of the trapezoid. And we're going to find x. Okay, we know 10 is equal to half, which is half of this and this. Or we can say this is the average of the two bases. So that would be x minus 3 plus 2x minus 4. And we can combine the like term. What we got here is 3x minus 7. And then we can times 2 on both sides. Then we got 20 equals 3x minus 7. And I like to put my x to the left. So we got 3x minus 7 equal to 20. To solve that, actually pretty easy. Just add 7 on both sides. Then 3x is equal to 27. Then we divide by 3. Then x is equal to 9. So that's how we find x. But actually, we can plug in and see. We can verify it. So plug in x minus 3 will be 6. Here is 2 times 9 minus 4, which is 18 minus 4 is 14. So this is a 14. And this is 6. 6 plus 14 is 20. Half of that is 10. So we know we got that right. Okay? Good? Yeah. Mia, we good? Hello, Mia. Are you there? Okay. All right. Now here, the verification, this part is always important, and we unfortunately no we don't do the verification we know enough. We just solve the problem, find x, and we say that's end of it. What which is not. We actually have to go back and to verify it, to check it. Okay. All right. So that's what we have for today. I'll send you the problems tonight. Okay, make sure you got that done. All right. Bye.